Afternoon once again, Infra Day. It's great to be here. Ken, thanks for having us back. We do a lot of Infra Days, so we appreciate the partnership. Today, we're going to be talking a little bit about how we can advance California projects much quicker and much safer. Let's dive in. The Common Ground Alliance, which is an association of damage prevention professionals, put out in their 2022 DIG report that 94% of all utility damage can be traced back to a lack of accurate mapping infrastructure. You dive into some of the details of locator error. Here are the common pitfalls. Some of these you might recognize: incorrect records, abandoned lines, locator error, big challenges, big potential challenges to safety. Let's talk speed. This was just a conversation I had this week with a technology leader at one of the big engineering firms. It's not uncommon that a client is telling us to go really fast, and we're spending most of the time on utility location. And that's because utility location is really difficult. It's time consuming. There's information all over the place, GIS systems. Your project owners may be handing you as-built, or project owners, you know what some of those look like, napkins, etc., that kind of tell you where some of this stuff might be. And this presents a huge risk to our project execution by way of delays or whatever it may be. So the question is, how can we do better? Feel free to shout out some answers. Yeah. So this question was asked at the same Common Ground Alliance convention this week, and my colleague was at the show. And they had one of those little, you text in and it tells everyone the answers based on the crowd. Mapping and AI were the two big components that folks in that audience thought could help advance how we can provide better utility data infrastructure. So that's something we have a lot of ideas on. So how would you do it? Well, you would want to create an AI conflation engine. The first thing you would do is you can imagine out in the world, there is thousands of GIS databases. There's county, state, municipal, federal, all sorts of vector data. So you pull that and start to conflate an initial model. Combine that with as-built out in the public domain. Next, you would detect and validate those records to confirm the accuracy and find additional lines that may be omitted from the records or may be inaccurate. And then lastly, you need to continue to collect and update the data. Here's an example of how you might stitch together vector data from all over the country by way of GIS systems and geotagging as-built. When you put this together across the country, it might look something like this. But if you put this somewhere more locally, it might look like something like this. This is Century Boulevard in Sepulveda near LAX, and this is a synthesization of many publicly available records as built to start to put together a base map of utility infrastructure in the area. Here's a real-world example of this. I had the pleasure of working with Caltrans District 5, who deployed this technology for the Middle Mile Broadband Project. As you can imagine, there's hundreds of miles of segment that needs to be studied in order to identify where on the road should you put that fiber. And so we took an 8-mile segment, and this is out in pretty rural California, as you could see. And basically, we populated on-surface objects and utility lines in that area. The Caltrans engineer told us that this would have taken probably 7 or 8 weeks with all their other responsibilities. We delivered it in a week. And on top of that, the contractor in the CMGC contract was able to better identify a potholing plan and potentially reduce utility relocations down the road when we get into construction. But that's not all. You might get into detecting and validating all of that data. Here's a couple interesting examples. So when you go in and go through aerial imagery, street view photos, you find a lot of interesting things. On-surface objects, trench lines, anything from old construction photos that show previous trench lines in the ground. Can really lend a lot of clues, flags, old 811 markings. This provides clues that can be harnessed using change detection. Put those together, and you can get the most robust starting point done 100% remotely to provide a great start to any project. Here's a real example. This one's out in Oxnard. So you'll notice this communication line. Take a look at C2. Pretty much all the other lines were found in the records and they were verified visually, but C2 was not visible or was not detected in the public records. So how do you find it? Well, you take that 4-mile project area, you visually validate every line, but then you find additional information. So road repair, top right, bottom left photo, spray paint marking, we can say with a great degree of confidence, there's a comms line there. Lastly, you need to collect and update the records. Here's an example of one of our partners. They gave us 185 documents to use to enrich their project. So you add that to the data lake, it adds more data that can be used for the research process and create an even better model that can be returned to the client. Here's a few more anecdotes from our friends at Caltrans talking about the speed and the accuracy of which the data provided to them and was able to help them move quicker and accurately. And folks, if you are interested in learning more, here's a couple of my colleagues who are going to be hosting a webinar next week. You can just scan the QR code and you can register for that webinar. Additionally, myself and Sam right here will be out in the foyer. You're welcome to come by and ask us any questions. Thank you.